Lesson 12.2 is about pyramids. Okay, so now some basics about pyramids. Pyramids have one base. The base is a regular polygon. All of the base has edges, and each edge is the same length, making it a regular polygon. The base could be a triangle, a square, a pentagon, a hexagon, an octagon, and so on. The height of a pyramid is measured from the very center of the regular polygon, that's the base, to the vertex, which is the top, the point where all of the lateral faces meet. The lateral faces in a pyramid are all triangles. So in this example, on the square pyramid, there are four sides to the base, to the square, and so there are four triangles that all converge and come together up at the vertex. Again, we measure the height, h, from vertex to the center of the base. And then when we look at each of the lateral faces, on the one on the right, I have drawn a slant height. Each lateral face is a perfect isosceles triangle. On the two legs of the isosceles triangle are the lateral edges of the pyramid. And the line down the middle, the altitude of that lateral face, is called the slant height, and it's involved. We use the slant height when we use some of the formulas. So those are the parts of and some facts about pyramids. So the formulas for finding the surface areas and volumes of a pyramid are here. First, the lateral area, so it's the sum of the areas of the lateral faces of a pyramid, is equal to 1/2 the perimeter of the base times the slant height. The total area then is equal to the lateral area plus the area of the one base. And the volume of a pyramid is equal to 1/3 times the base area times the height of the pyramid itself. So let's see how these work. Okay, so in this example, we're looking at a square pyramid, and the base is a regular square, and the base edge is 6, so that means all the base edges are 6, and the lateral edge is 5. That means all of the lateral edges are 5 long. So we're going to go ahead and find the lateral area, the total area, and the volume of this pyramid. So my suggestion always is to start with the base and find the perimeter of the base and the area of the base, which I call capital B for base area. So the perimeter of this base, because all of the sides are 6, is 4 times 6, or 24 units. And the base area is 6 squared, side squared, or 36 square units. So we'll be using those. We use the perimeter to figure out lateral area, and we use the base area to figure out both total area and volume. So let's look at what we've got here. What we want to do is, starting with lateral area, is equal to 1/2 the perimeter times the slant height. So we're going to need to find the slant height. So I'm going to draw in a line on this right lateral face. That's the slant height. Now, I know since this whole side of the square is 6, that half of it, because I know that altitude of where the slant height line is, hits the midpoint of that base edge. This part is, that part is 3. So I'm looking at that little isosceles triangle, and I have 3 blank 5. So I know that the slant height now is 4, that's a 3, 4, 5 Pythagorean triple. So I could say the lateral area is 1/2 the perimeter, which I already figured out, so times 24, times the slant height, which I just computed as 4. So this is 48 square meters. Let's say that our units are meters. So this is meters, and this is square meters. Okay, so next the total area is equal to the lateral area plus the area of the one base. So we already figured out the lateral area up above is 48 square meters, and we figured out the base area earlier is 36 square meters. So altogether, that's 84 square meters total area of the pyramid. Now, in order to find the volume, we look at the volume formula. It's 1/3 the base area times the height. Well, I already have the base area. I found out that that was 36. So I really just need to find the height now. So in order to form the height, I'm going to connect a little segment right here between the center of the polygon of the square and the midpoint of one of the sides. So I'm going to redraw that little triangle out here. Because I know that this piece, I'm going to sort of underline it in red right here, is half of the edge of a square, I know that that's 3, because it goes from the center of the square to the edge. So that's 3. And I know that the slant height is 4. That is the hypotenuse of that little right triangle. And so what I'm trying to find is h. So if I set up a little Pythagorean theorem equation, h squared plus 3 squared equals 4 squared, I will get that h is equal to the square root of 7. So square root of 7 is the height of this pyramid. So that goes here. Then I finish my computation. 1/3 of 36 is 12 times the square root of 7, and that is in cubic meters. So that's just a little example of how to go about finding the areas and volumes of a pyramid. So in this next example, we have a triangular pyramid. So the base is a regular triangle, and the height of this pyramid is 6 centimeters, and the radius of the base, so from the center, the distance from the center out to a vertice of the triangular base is 8 centimeters, and we're asked to find the volume. So the first thing we should do is frame the formula. Volume is 1/3 of the base area times the height. Okay, well, we already know that the height is 6, and we know the 1/3. So what I want to do is find the base area. So I'm going to redraw. I'm going to take a bird's eye view as if I'm sitting on the vertex looking straight down on the base. And I can see that this base radius of 8 is the distance from the center of the triangle out to the vertice. So if that's 8, I want to be able to find the area of this base, because I'm going to need to find the apothem and the perimeter of the base to do that. So I remember 3 sides, 30-degree bottom for a regular triangle. So that means that the apothem is the short leg. So if the hypotenuse of that little right triangle is 8, then the short leg, which is the apothem, is 4. And long leg, which is the 60-degree angle, opposite the 60-degree angle, is short leg times root 3, so 4 root 3, meaning that this entire side here is 2 of those, or 8 root 3. So to find the base area, I can use 1/2 the apothem times the perimeter, and I'm just looking at the area of this triangle. So it's going to be 1/2 the apothem of 4 times the perimeter. Now, if one side is 8 root 3, then the perimeter is 3 times 8 root 3, or 24 root 3. So the base area is 1/2 times 4 times 24 root 3, so that is 48 root 3. So this one is a little more, sometimes it's a little complicated to find the area of the base, but that's what I'm going to use in my formula here. So the volume of this triangular pyramid is 1/3 times 48 root 3 times 6. So we get 1/3 of 48 is 16 times 6. We get 96 times the square root of 3, 96 root 3 cubic centimeters. And that's the end of the lesson on pyramids.